Take a look at the equation given in the Tray 1 section of your handout. In this first equilibrium, the reactants include a complex ion with a copper-2 ion surrounded by water molecules, while the products include a complex ion in which the ligands around the copper-2 ion are chloride ions. The part that we are going to focus on today is that the complex ion on the reactant side is a different color than the complex ion on the product side of the equation. As you can see, the color of the system is initially aqua. As with all of these systems, I've set this one up so that the initial color is a mixture of the color of the reactants and the color of the products. Or, in other words, the reactant color and the product color mix, in this case, to form aqua. So let's see what happens if I add more water. It was fairly subtle from this angle, but hopefully you could sort of see that it went from aqua to a now blue solution. Now it is time to assign colors to the two colored substances in the equilibrium. When we have fairly equal amounts of both complex ions, the solution is aqua. When we add water, it becomes more blue. It's very important that you look at the equation on the handout while I go over this part. This is a little tricky because we know that changing the amount of a liquid shouldn't shift an equilibrium. However, what the added water does is dilute all species equally. On the reactant side, 5 reactants, 1 complex ion, and 4 chlorides are being diluted. On the product side, 1 substance is being diluted. So which way should it shift? Okay. Hopefully you said it should shift to the Hopefully you said that it should shift to the left because the overall concentrations of reactants are being decreased to a greater extent. Kind of complicated, but hopefully you got that. So, I added water and it shifted left and turned blue. What color is the complex ion that contains copper surrounded by water molecules? Okay, so you can write blue under the formula of that ion. Now you get to practice your color theory skills. When both colored complex ions are present in large extents, the solution is aqua. When mostly the reactant ion is present, the solution is blue. So, what color would combine with blue to make aqua? Did you think of green? Good. Green and blue would combine to make aqua. And if you didn't think of that, that's okay, because you're going to get lots more practice. So, our prediction would be that the complex ion on the product side would be green. Go ahead and write green under that ion. Okay, this is what you'll do for all the equilibrium systems. The demo part will start with the color of the mixture of reactants and products. I'll add a substance so that we see a shift, and you can determine the color of either the reactants or the products based on the shift. Then you'll deduce, I really like that word, you'll deduce the color of the species on the other side. Have fun!